Welcome to Wire Services, providers of transmission line engineering services. Wire Services brings together all engineering expertise required for design support for new transmission and distribution lines, NERC-compliant thermal rating assessments of transmission lines, specifying upgrades to transmission systems, and providing NERC-compliant vegetation assessment reports, all in a one-stop consulting engineering firm. All of these services are made possible by LiDAR. What is LiDAR? LiDAR is an acronym for Light Detection and Ranging. In short, lasers are used for accurate high-speed surveying. Data is typically gathered by airborne helicopters or fixed-wing aircrafts. Wire Services utilizes established LiDAR suppliers to deliver quality products to meet the needs of each customer. Typical LiDAR survey products to expect include high-resolution and accurate LiDAR point data collected on visible objects within transmission line corridors. High-resolution orthophotography captured observing downward during the LiDAR survey collection. Forward-looking video, which is available in standard definition to assess and audit the overall condition of the right-of-way, as well as in high definition if a more detailed audit of line structures is required. Detailed high-resolution tower photography of the line structures may also be gathered. Local weather conditions and electrical line loading data are also collected for thermal rating and upgrade studies. After all this data has been gathered, Wire Services can perform its many service offerings. At Wire Services, one of our core abilities is to perform thermal rating analysis of existing transmission lines. Transmission lines are modeled with PLS-CAD or TL Pro to determine ground and object clearances at any conductor temperature. Here is a typical raw, unfeatured LiDAR point cloud collected on a transmission line. You can see the various features like the structural steel members, conductors, guy wires, other lines, and terrain features. Here you can see the post-processed LiDAR data classified into unique feature codes. Feature codes are assigned and colorized to objects found in the survey. Individual tower members and conductors are collected. The vegetation canopy along the line is collected in high detail. Visible features like roads, rivers, bridges, and railway tracks are also collected. Building surfaces are accurately portrayed and coded. After all objects are feature-coded, the deliverable is a fully feature-coded model, which accurately depicts the conductor sag and position relative to any LiDAR point in the model. Points collected on the ground terrain may be used to create a triangulated irregular network, or TIN model, which can be displayed as contour lines, or displayed as a solid surface. Orthophotography collected during the LiDAR flights may be draped onto the TIN model for a realistic representation of the surveyed right-of-way. Shown in this example is a city in Central America. After the model has been coded, analysis can be performed by creating simple stick structures or detailed 3D structure models. Shown here are examples of detailed structures modeled in PLS-CAD, guide steel and wood structures of any configuration and voltage type. Thermal rating analysis requires a feature-coded point survey of the conductors, the right-of-way ground terrain and obstacles, and the conductor temperature at the time of survey. The conductor temperature is calculated with the electrical load and local weather conditions present during the time of the LiDAR survey. This operating temperature is known as the base case. All future operating conditions are extrapolated from this case in PLS-CAD. In this example, the LiDAR points on conductors were collected at a base case of 27 degrees Celsius. The conductor sections in PLS-CAD are sagged to match these points, which establishes the sag and tension properties of the as-built base condition. Visible in this view is the centerline ground elevations along with the clearance line that the conductors must stay above at all conditions. Watch what happens to the sag as the temperature increases from 27 degrees to a maximum of 100 degrees. By 50 degrees Celsius, there are multiple points of clearance line encroachments. At 100 degrees Celsius, these encroachments become very serious and may require mitigation if operation at this temperature is considered. The thermal rating of this span is defined as the conductor operating temperature of the span when it first crosses the clearance line over the right-of-way or objects. Here is the same span shown in a three-dimensional view taken from PLS-CAD, displaying the conductor locations encroaching past the clearance line. A vertical red line connects the conductor to the nearby ground point, causing the clearance violation. In this three-dimensional view, PLS-CAD is displaying the clearance between a transmission line to a crossing distribution voltage level wood pole line with the actual clearances labeled in red. If required, the crossing distribution line can be modeled and the clearances between both upper and lower lines can be studied under a multitude of operating and weather cases depending upon client specifications. Wire Services also provides vegetation analysis of the right-of-way. LiDAR and PLS-CAD are ideally suited to detect vegetation encroachments under any static or wind-driven weather case. By simulating wind conditions, we are able to detect blowout vegetation encroachment on the transmission line. Here, the conductor is blown out towards the vegetation canopy, and the red points are depicting clearance violations. In this view, the yellow points display falling tree violations, where the red depicts grow-in encroachment. Shown here is an actual deliverable report printable from PLS-CAD on vegetation encroachments detected along a 230 kV line and provided to a client to schedule tree trimming. In addition to thermal rating and vegetation studies, our experienced engineering team can provide a full range of transmission and distribution design services from conceptual stage to construction implementation and contract management. Shown here is a new line design project designed in PLS-CAD and displayed in Google Earth. Detailed design support is provided with any new design project. Wire Services can compile plan and profile drawings of any design in any drawing format, as well as provide route selection studies assessing multiple corridors. Wire Services also provides upgrade engineering solutions to increase a line's rating capacity. We can initiate an economic analysis of upgrade methods and tailor a solution compliant with your company's operating methodology. Shown here is a pole class changeout on a 230 kV line, thereby increasing the line security. Shown here is a 5-foot tower extension inserted into a 115 kV steel tower to resolve clearance issues. The phase raiser method is an upgrade option that can raise the line while energized. A metal structure is attached to the wood pole to maintain its structural integrity. Then the pole is cut and the upper portion of the tower is raised to a safe clearance. The end result is as strong or even stronger than the original wood structure. Often, depending upon the height needed and soil conditions, a ground reinforcement kit is needed to maintain foundation stability. Wire Services can assess these requirements and implement a working solution for just about any transmission line. Like the phase raiser, AmpJack is a new patented method developed to lift steel towers with height extensions while the line remains energized. Mid-span conductor retensioning is another upgrade method. Retensioning can be performed using an implo sleeve. A section of the conductor is cut and an implo sleeve is placed on the remaining ends. When detonated, the sleeve instantly fuses the conductors for a full tension dead end. The resulting fused compression weld is stronger than the original conductor itself. With an implo sleeve or dead end, the time and expense required to install dead ends or conductor joints is reduced to a fraction of the time taken to install traditional compression-type hardware. Additionally, due to the quality of the joint, line operations at high conductor operating temperatures may be considered without significantly degrading the connection strength over time. For more information on what Wire Services can do for you, contact us at www.wireservices.ca.